Hello everyone. Now in this video we are going to discuss question number 36 of GATE Day 25 exam, and this question was asked for 2 mark here. Okay, so let's read the question carefully. Let y equals to z square, and what is z? Z equals to x minus mu divided by sigma here, right? Where x is a normal variable, normal random variable with mean mu and the variance sigma square you can see, and we need to find out the variance of y, right? Now tell me, what is this? We have discussed this in our course. If x is a normal variable, and if we subtract it from mu divide by standard deviation here, what does this mean? It means that z is a what? Standard normal random variable. It is a standard normal variable having mu equals to 0 and deviation equals to what? 1 here, right? This is what z is. So from the given information we can say that z is a standard normal variable like this having mu 0 and deviation equals to 1 here, right? Now what we need to find out, variance of y equals to z square here, right? Now, if z is a standard normal variable and we are taking a square of that, what is this one? So this is basically a what? If we look at the definition of chi-square distribution here, right? If we square the standard normal variable, if we take a square of a standard normal variable, that is what a chi-square distribution here. Chi-square distribution here, right? So denoted by like this chi symbol, right? Chi-square distribution here. So this is basically what? It is a chi-square distribution having degree of freedom 1 here, we can say the degree of freedom 1. So please watch my videos on chi-square distribution and what is degree of freedom in the case of this chi-square distribution here. So degree of freedom 1 here you can see, right? So what we can say, y is basically what? Follows a chi-square distribution here with the degree of freedom 1, right? Now what is this? If y follows a chi-square distribution with a degree of freedom 1, what is the variance of y here? So variance of y is basically equals to 2k, where k is basically what? K is equals to number of degree of freedom, okay? In the case of chi-square distribution here talking about. So here the value of k is basically equals to 1. So that's it. The variance of y is basically equals to what? 2 into 1 is 2 here. Simple question for a 2 marks here, right? So option B is correct here. So in this way you can solve this particular question if you understand the concept of chi-square distribution here. But suppose if you don't understand the chi-square distribution here, let's try to solve this question in a different way, okay? So here you can see, let's try to solve this question in an alternative manner. Second method, we can say method equals to method second here. So we know that z is a standard normal variable. Okay, fine. So z is a standard normal variable having mean mu and the deviation 1. That's it, right? So what is variance of y here? Variance of y, how we can calculate this one? This is basically equals to what? Expectation of y square minus expectation of y whole square here. That is what variance of y. This is how we find out the variance of y, right? Now how to find out the expectation of y here? Expectation of y is nothing but expectation of z square, right? So how to find out expectation of z square? So we know that the variance of z is equals to what? Expectation of z square minus expectation of z whole square, right? Now here, what is the variance of z? If z is a standard normal variable, that is basically equals to 1. Expectation of z square minus what is the mean of, or we can say expectation of z, where z is a standard normal variable. So expectation of z is basically mean, that is basically equals to 0. So this is 0. So from this we can get expectation of z square equals to 1. So that's it. So we got this particular value here, expectation of y. So that is nothing but expectation of y, we can say, right? Now what about this one? Expectation of y square. How to find out expectation of y square here? Expectation of y square is equals to what? Expectation of a z square here, right? That is basically expectation of z to the power 4 here. Can we say like this? Yes. Now, if z is a standard normal variable, what is the expectation of z to the power 4 here? So we need to find out this one, right? So this is basically what? So z is a standard normal distribution. Okay. So we can say it is a fourth moment of standard normal distribution here. Since the z is a standard normal distribution and it is a fourth moment, so we can say that expectation of z to the power 4 is equals to what here? That is basically 3. Okay. So how we got the expectation of z to the power 4 is 3 is something we have discussed in the lecture. So please watch that particular video here or tutorial here. Okay. So fourth moment of standard normal distribution is what? 3 here. Remember this. So that's it. We got the expectation of y. We got the expectation of y square as well. So now we can use this particular formula. So here expectation of z square is basically equals to expectation of y is equals to 1. So variance of y will be what? Expectation of y square, that is equals to expectation of z to the power 4, that is 3 minus 1 here. So answer is 2. You can see the correct option is option number B here. I hope you understand what we have done in this particular video. So this all are simpler thing, but the main important point is about this particular thing. The fourth moment of a standard normal distribution is what? You can see here. So in general, we can say expectation of z to the power n, okay, where n is even. If n is even, then we can say this equals to what? N minus 1 double factorial. Okay, this is what thing you need to note. If n is odd, that is basically equals to expectation of Zn is basically equals to 0 if n is odd. So you can note down these two important point as well. So remember, this is basically a double factorial. So this we have differently than our factorial. Okay, remember this particular point. So I hope you understand what we have discussed in this particular video. And method 2. In method 1, simply if variance of chi-square k, we can say if k is a degree of freedom, that is basically equals to 2k. So remember this important point as well. Okay. I hope you understand the video solution of this particular question. Thank you.